Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture I am trying to explain E-greedy algorithm with some numerical example. How E-greedy algorithm suggests the player which mission he can choose so that he can get more returns. It is a part of multi-arm bandit problem. First thing is, as part of this algorithm, first thing is we have to provide the details of multi-armed bandit missions in a casino. Let's assume there are three multi-armed bandit missions. One mission is called A, another mission is called B, and another mission is called C. So three missions are there. And you can see here, when you played first time with mission A, it will do 3 rupee return, that is you. And second time 4 rupee return, and third time 2 rupee, and fourth time 5 rupee. Similarly, for the mission B, when anyone played for the first time, when it participated first time in a play, then it gives 6. When it participated second time, 7 rupee. For a third time, 5 rupee. For a fourth time, 8 rupee return. Similarly, mission C also, when it participated first time 4 rupee, second time 3 rupee, third time 5 rupee, and fourth time 4 rupee return it will give. Then you may have a question that everything is available now. So why E-greedy is required to tell which mission to go so that you got a more return? Because how much return the mission gives it is available, then what's the need of E-greedy? Actually, this data is not available. Only for the calculation purpose, I am assuming that this is the data. But actually how much return that mission will give next step, we don't know. We have to estimate, and accordingly we have to suggest. This is the data I have provided only for the numerical calculation purpose only. Done. Fine. Coming to this first step, this is called as the knowledge preparation, or for E-greedy algorithm implementation, we require some basic knowledge about the mission, how much returns that mission, every mission is giving in the previous runs, previous plays. But as of now, cache is open for the first time. The mission is not experienced a single play also to know how much returns are there. So maybe randomly the employee of the casino, he will go with mission A and he will play. In later he will go to the mission B, he will play. Later he will go to the mission C, he will play. So that we got the initial reward data. Okay. So let's assume first that the employee go to mission A and played with this mission. Then he got a reward of, when the mission A participated for the first time, what the reward? 3 rupee. So reward he got the 3 rupee. Similarly, when he went to mission B and he played with the mission B, then how much return? Because the B will be participated for the first time, so this will be the 6 rupee. Similarly, C mission, the player go to the mission C and played there, and what is the return? For the first time C is participated, so reward equal to 4. Now we have to update a small table. So one is called as the number of plays. I can call it as a n play table or n table, or you can call it the n table. So this contains how many times each mission participated in the play. So let us assume A, mission B, and mission C. See, when the employee started with mission A, this is the first time, so you update 1 here. And similarly, you have to update the reward table also. The reward table also you have to update. In the reward table also we have the 3 rows because we have the 3 missions. First row mission A, second row mission B, third row mission C. When A is participated for the first time, what is the reward we are getting? That is the 3. And later the employee went to mission B and he played with mission B, the reward equal to 6 rupee. So mission B, this is the first time, so keep 1 here. And what is the reward? When the B is the first time, that is the 6, so reward equal to 6. Later he went to mission C and played. So he first time C participated in the play, so it is a 1. And what is the corresponding reward? 4. That's over. That's over. Okay. So this is there are already 3 plays are happening in casino. One on mission A, one on mission B, one on mission C, and all the plays done by the employee for the initial data preparation. Similarly, you have to prepare the Q table. That means Q table means estimated Q values. So again it is the 3 rows because we have the 3 machines. Okay. So now when A is participated for the first time, what is the Q value? For that one first we have to write the Q. Q of machine equal to Q volt of corresponding machine plus reward of that machine divided by Q volt of corresponding machine divided by number of plays on that machine. Clear? Now you can see we are working with the A. So Q of A equal to old A value, that means old written on the machine A, reward minus old written on machine A divided by number of plays on the machine A. So you can see this is the first play, right? This is the first play. This is the only first play. So old value 0 plus what is the reward value? Reward value is 3. So reward value 3, old value 0. Number of plays only 1. So this is the 3. So it is updated as a 3. Similarly, when you go to machine B, so that means Q of B equal to old Q old of B plus R minus Q old of B divided by N of B. So because the B played for the first time, so previous value will be 0. What is the reward you are getting? 6 rupee. So 6 minus 0. Number of times it participated only one time. So this is equal to 6. So this will be updated as 6. Okay. Now similarly Q of C equal to old Q of C value, because now he moved to the C machine, plus reward minus Q old of C divided by N of C. That means Q old is plus 0 and reward value R equal to 4 minus old value, that's equal to 0 divided by 1. So now it is 4. Now it is 4. That's all. So I got all the initial data. Now we will implement the E greedy algorithm. So this will be our next step. Okay. So in E greedy algorithm, first we have to initialize the epsilon value, that's equal to 0.2. I assume. So generally the epsilon value we choose a small value. So if you choose epsilon value small means exploration is happening rarely, exploitation will be frequent. Whereas epsilon value large means there is a more exploration and less exploitation. So the epsilon value will help you to balance the exploration and exploitation. Generally we will prefer more exploitation and less exploration. That's better. So epsilon value I consider as epsilon equal to 0.2. Now randomly generate the value R. Randomly generate any value. Let us assume I choose R equal to 0.1. Now check if R is less than epsilon or not. So you can see here R value is 0.1 and epsilon value is 0.2. So it is S. If it is S means it is exploration. It is exploration. Exploration means you can choose any one of the machine randomly. That means from A, either B or C, you can choose any one machine randomly. Like that you have tried the code. Let us assume randomly we have chosen the machine A. The program randomly chosen machine A. That means we are suggesting the player go and play with machine A. That means the player go to the machine A and he will play. Then what is the play number? That's equal to 1. So for the first time when the player want to play, then he chooses the machine A and this will be 0 and this will be 0. Because in the second, this is the user first play. Okay, when the user first play, he chooses the machine A, not B, not C, that's updated. Then A is participated for the second time. When the A is participated for the second time, what is the reward? 4. So it will be the 4. So this is the first play by the user. This is the play 0. I can represent this one as a play 0 by the employee, this one. Initial play. Play 0 means it contains 3 plays. So first play by the user. So because he chose A, he played with A, it gave the return of 4. and there is no return from the B, no return from the C because it's not chosen. So reward value R equal to 4. So when he chosen A, then R equal to 4, then you have to update the Q table. So Q of A equal to Q old of A plus reward minus Q old of A divided by N of A. So what is the Q old of A? What is the previous Q old? 3. 3 plus what is the reward? 4 minus 3 divided by number of plays, play number 1 and play number 2. So total sum of these two is the total number of plays as of now. So divided by 2. So this value equal to 3.5. So you can update here, it is a 3.5. So this is the play 1 by the player. So B and C not participated, you can copy the same values here. No need to update it. That's it. So first play completed. Let's assume the user or player want to go with 3 plays. Let's assume 3 plays. So first play completed. Now go to the second play, and later we have to work with third play. Similarly, here is the second play, and this is the third play, and this is the second play, and this is the third play. We will do one by one. Now, so first play completed. This is corresponding to the play 1 by user. Now we will work with play 2. Second play. So as usual, epsilon value is 0.2. Randomly generate R value. Let us assume R value equal to 0.5. Let us assume. Then what happened if R value less than epsilon or not? R value is a 0.5 and epsilon value is a 0.2. So it is a false. So if it is a false, then we go for the exploitation. So exploitation means you have to choose the machine which gives the more returns. Which gives the more returns. You can see here it is not 6 is copied. Similarly, you have to copy 4. Now coming to this exploitation means you have to choose the machine. You have to suggest the machine which gave the highest estimated returns. What is the highest estimated return? That is the B. So as per the exploitation strategy, your algorithm suggesting the user go and play with B. Exploitation means high estimated return machine will choose to play. So what is the highest estimated return machine? It is a B. 6 returns are there. Average or highest estimated return is 6. It is the maximum. So that is suggested here. Now that means the user go and play with machine B. So that means in the second play by the user, he chooses the machine B. So A equal 0 and in place of B it is 0. So he chooses the machine B. So when he chooses the machine B, what is the reward? For the first time, B gave 6 rupee. And this is the second time, it gave the 7 rupee. So this is the 7 rupee return. So this is the 0 and this is the 0 because A and C not participated. So what is the reward here? During this exploitation, reward equal to 7. Now you calculate the estimated returns. Q of B equal to Q old of B plus R minus Q of B divided by N of B. So that's equal to what is the Q old of B? So old Q value 6 plus reward is 7. Old B value 6 minus number of plays. Number of plays are 1 and 2. So total number of plays happening on the machine is 2. So now we have the 6 plus 1 by 2, that's equal to 6.5. So this is updated as 6.5 because A and C not participated, their values will not change. That is 3.5 and 4.5. Like this. Clear? Now, so maybe this time you can go with play 3 because the user want to go with 3 plays, play 3. Then as usual your epsilon value is a 0.2, randomly generate the R value. Maybe R value is 0.05, let us assume. Then if your R value is less than epsilon, R value is 0.05, epsilon equal to 2, so it is a true. When it is a true, then we go for the exploration. Exploration means you can choose any one of the machine from A, B, C. Okay, so let us assume this time the algorithm randomly chooses the machine C. Let us assume. I'm not saying that it is a fix. Let us assume randomly choosing the machine C. So that means then what the player will do? He go to machine C and he play with that one. When he play with that one means this third play he go to the machine C. So this will be the 1. So it will be 0 and it will be 0. And you can see machine C participated first time by the employee and this is the second play on the machine. Now this is the by the player. So 2 times he participated. So second time how much return it will be? 3. So it will be 3 return and 0 and 0. So here in the exploration reward are equal to 3. In exploration reward are equal to 3. Right. So now you can update your Q of C value. So Q of C equal to old Q of C, old QC plus reward minus old Q value for the machine C divided by number of plays on that machine. So what is the old Q value? That is the 4 plus what is the reward value? That is the 3 minus 4 old by number of plays. So you see number of plays happening on the machine. So this is the play number 1 and this is the second play. So this will be divided by 2. So we have the 4 minus 1 by 2, that's equal to 3.5. Now it is a 3.5 and these values, the B and A not participated, their values are not updated. Like that he played 3 plays are completed. This is how the updated Q table, updated reward table and updated N table. Now I want to calculate total returns. So what the total return the player got? Total return the player got from this as per your E-grid algorithm. So he got 4 rupee in the first play, 7 rupee in the second play, 3 rupee in the third play. So total returns are 4 plus 7 plus 3, that's equal to 14. And average returns. So you have to calculate the average returns. Average returns means first play 4, second play 7, third play 3. So total number of plays 3. So that's equal to 14 by 3. So 14 by 3 means 3 4 jar 12, 3 6 jar 6 6 like that he got. So on average he got the 4.6 rupee from each play. So this is how your E-grid algorithm works. This is how your E-grid algorithm suggests the players which machine they can choose to play in a casino. So this is related to the multi-armed bandit problem. And I hope you understand these calculations. So thank you, and in the next lecture we will come up with some other topic. Until then, bye, thank you.